Good afternoon. Today we discuss about the quality management. It costs a lot to produce a bad product. What does quality management encompass? TQM is encompass philosophy, management philosophy, continuous improvement, leadership development and partnership development. Today we discuss about the third control tool, that is the control chart. Now what is the control chart? It is a performance matrix. The quality is management all about try to manage all aspects of organization in order to excel in all dimensions that are important to customer. There are two aspects of quality: features, that is more feature that meet customer need, higher quality, that is the freedom from trouble, that is fewer defect, is equal to high quality. The Edward Denham introduced the different definition of the quality, that is uniformity and dependability. We focus on SPC and statistical tool and PDCA method. Juron also introduced the quality definition, that is fitness for use, introduced the Pareto principle, cost of quality, general management approach as well as statistic. The control chart is a graph used to study how the process changes over time. Data is plotted in the time order. A control chart always has a center line for the average, the upper line for the upper control limit and the lower line is for the lower control limit. These lines are determined from the historical data. Means if we have a data, that is historical data, in that case we can plot a graph that is the up to the upper control limit and the lower control limit. Between these two limits there is a one line that is called as a central line. So this is always called as a central line, and is the average of this line, and the two limits are there, upper control limit and lower control limit. The control charts are used to routinely monitor the quality. Depending on the number of process characteristics to be mentioned, there are two basic types of control chart. The first is referred to unvariant control chart, is a graphical display, that chart of the one quality characteristics, and the second referred to a multivariant control chart, is a graphical display of a statistic, summarizes all the represents more than one quality characteristics. Example over here: consider a capability of a process that put pressurized grease in the aerosol can. The design space called for the average of 60 pound per square inches of the pressure in each can, with an upper limit tolerance is 65 psi and the lower limit tolerance is of a 55 psi. A sample is taken from the production and it is found that the cans average 61 psi with a standard deviation of 2 psi. Is the process capable for the 3 sigma level? What is the probability of producing a defect? So here is the solution, that is a lower tolerance limit, it is a 55, upper tolerance limit is a 65. So by using this chart, that is the sigma x square is equal to 61 over here. So CPK is equal to minimum of x bar minus LTL upon 3 sigma and UTL minus x bar upon 3 sigma. So here we can find out the minimum of one, that is a 10.666 is equal to 0.66667. So no, the process is not capable at a 3 sigma level. So here is the control chart, that is the upper control limit, central line and the lower control limit, and between these two lines, upper control and lower control, the different data points are first find out and plotted, and then we can join these data point and we can form the control chart. Control chart tell us about a process measures in exhibiting abnormal behavior. Two types of control chart: X bar R chart. This is a plot of average and ranges over time used for performance measures that are variables, and P chart is used to plot a proportion over time used for performance measure that are yes or no attribute. statistical process with P chart. When decisions are simple, yes or no by inspection. When the sample size is large enough, that is greater than 50, in that case P chart is used. So these are the sample, day and items, number of items per day, defective pieces and the percentage. So we can find out from this data. So here is a P bar is equal to total number of defects upon number of samples into sample size. SV bar is equal to P bar up into 1 minus P bar bracket upon N. So UCL is equal to P bar plus ZS upon P bar, ZS P bar, and LCL is equal to P bar minus ZS P bar. Now from this statistical process we can find out the UCL and LCL. So it is a 0.117 and 0.015 carried out the figure. So we find out the chart. Here is the control chart. So data points are plotted over here and find out the your middle line over here. So this is the P chart. What is the XR chart? It is not possible to label good or bad. If we have relatively smaller sample size less than 20, in that case we use this chart. So here is the formula, that is define the upper and lower control limit. So this is the X chart and X bar chart. So upper control limit and lower control limit, and these are the data points over here. Thank you very much.